So we'll continue with uh, we'll continue with the second part of the interest rate risk, and this time we have to use a lot of market value accounting. So of course, in the academic setting, it will not be a big problem because we see the items like partially, right? But in real life, you could imagine, like if we are a financial institution, we'll have a lot of like items, hundreds of items, thousands of items that we have to measure, right, from time to time. And if we talk about market value, you can imagine, right? You have to determine the market value of each item. Again, in the academic setting, we don't really care about the accuracy of the estimates, but in real life, when we talk about the real money on every item, then the accuracy would be a big question, right? A big key to the what's that? Our estimation. Okay, so this chapter we'll see uh, duration method, right? This is this is a method officially or officiated by the BCBS. Right, in previous chapter, we saw the repricing gap model. That is an internal model, not an official model regulated by the BCBS. But this one, the duration method, is the official model to measure the interest rate risk. Right? So let's go into it. So what is duration? Duration sounds very similar to maturity, but they are not the same. Okay, so they are not the same, but they sound similar, in terms of the vocabulary. So what is duration? Duration is actually time to maturity. See, they are similar, right? Time to maturity, but this is weighted average by the present values of cash flows. Okay, well, it might sound a bit complicated here, but it's actually very easy. So this is time to maturity, right? So duration is actually maturity or time to maturity, but this is weighted by the present values of cash flows. So the uh, positions of cash flows and also the what's that, the size or the magnitude of each cash flow becomes very important, or it plays an important role in estimating the duration. Right? So let's see an example here. Okay, so in this example, let's see so you lend out 100, right? You lend out 100, and uh, the principal will be paid in 1 year, right? But it will be paid twice, right? Every 6 months, and then the interest rate is 15% per year. So let me draw it here. This is just a simple example to describe the duration method. Okay, so let's say you lend out 100. You lend out 100. So I give minus to show that you disburse the money. Okay, this is cash outflow because you lend out the money. You lend the money, lend 100 to someone else. And the contract says that this would be paid in 1 year. So tell me again, the maturity is 1 year, right? The maturity is 1 year. See, very obvious. So in half a year, what will you get? 50, right? And the interest rate is 15% per year, 15% per annum. Okay, so how much is it? How much is the interest income? 15% of 100, but half a year.
15.
Yeah, 15, but
Ah,
half a year.
7.5.
Yeah, 750, right? So your cash flow would be 5750 for the first 6 months, right? What about the second 6 month? Again, you will get what? 50. This is the principal. What about the interest income?
It's the
Um,
same. Oh,
no,
sorry.
it would be 3.75
Yeah, 3.75 because
it's the second received payment for this year, and you
right.
have to do the denominator to the power of 2. So
This is more simple, I think, right? You have the interest rate is 15% per year for half a year, right? But now the principal is 50, right? Because you have got the principal here, 50. So only 50 remaining, right? You could imagine. So for the second 6-month period, you will get like 15% per year times half a year times 50 only, and not 100, right? Because you have got the first 50 back, yeah, in the first 6 months. So you're right, we'll get what, 375. Okay, so in total here it would be 5375. Okay, so now let's calculate the duration. Okay, again, the maturity, you know exactly that the maturity is 1 year, not a problem, right? One year is the maturity, but now we'll see the duration. Okay, so what is duration method? We also call this method Macaulay duration. Macaulay is someone's name. I think he was the first who published this method, right, in a journal. So we call it Macaulay duration, or you can call it simply duration. So duration is actually very simple. We start from the denominator, okay? The denominator is the present value of your cash flows. So you have cash flows, right? You have cash flows number one, right? Cash flow number two, cash flow number three, number four, number five, and so on, right? And if you discount it back, right? Discount every cash flow back at your discount factor or the interest rate, and then you sum them together, then you get the present value of your future cash flows. Right? You saw this a lot in other courses, I believe, right? In other accounting and finance or economics. Right? So again, the denominator is the present value of future cash flows. Right? Future cash flows are discounted back at a certain interest rate, at the existing interest rate, and then you sum them together. So what about the numerator? Is actually quite similar. So we have cash flows, I cash flow. So cash flow number one, number two, number three, number four, number five, and so forth. Right? And then we discount it back at a certain interest rate. But now, before we sum them together, right, we multiply by the real time. T is the time, right? The real time. And then we sum them together, sum them all, okay? So it looks complicated, but it's actually very easy. You'll see in a little while, okay? So let's apply this one. We have like two cash flows, right? Like this. And the interest rate is 15% per year. So obviously for half a year, this is 7.5%. Right, so let's start from the denominator. For this case, what is our denominator? The first cash flow is, what is it again? 5750 divided by, what is our interest rate again?
750.
7.5% to the power of 1, right? Because you see, it's one-time move, right? From here to here. So to the power of 1, because it's one-time move, right? Plus, the second cash flow is 5375 divided by 1 plus 7.5%. So to the power of 2. Why 2? Because there are two movements, you see, from here, right? 1, 2. See, one more time, right? 1, 2, right? Two movement or two moves. So that's why it's to the power of 2. Okay, and then Yeah, we can do it in Excel. So this is 57. 50, and this is 53, 25. Okay, so the first the present value of this one, 57 divided by 1 plus 7.5, right? 7.5% to the power of 1, right? And I can make a copy, right? But yeah, just for the sake of example, we do it again. 5375 divided by 1 plus 7.5% to the power of 2. Okay, then we sum them together. So we get 100. So 100 is the denominator, right? So now we have to do with the numerator, right? Numerator, remember here the formula? It's very similar to the denominator, except that we have to multiply each of the present value by the real time. Okay, so we need the real time here. So the first period, what is the real time? Half a year, right? And the second period is 1 year. Agree, right? This is the real time. This is the periods, okay? So in this case, they are different because we are doing the semi-annual system. So 2 periods, but 1 year. Okay. So oops. So we have to multiply the present value by the time here. Okay, so the first present value here multiplied by the time, and then the second one, this multiplied by this, right? We can make a copy and paste, and then sum together. Okay, so 73. Oh, we haven't written anything here, but can imagine that. So this would be 5750 divided by 1 plus 7.5% times 0.5, right? Plus 5375, 1 plus 7.5% to the power of 2 multiplied by 1, right? And then we get 7325. So what is it? What is the duration? Divided by this one, right? The numerator divided by denominator. You see, 0.73. You get the idea, right? What is the maturity again? Tell me, how long is the maturity?
1 year.
1 year, but the duration is only 0.73 years. How many months is it? Times 12? Yeah, 8.7 months, right? Okay. So here's the idea. The maturity is 1 year, but the duration is only 0.73 years. What's the meaning? Duration means this is the real period where actually you recoup all your investment, you get back all of your money. So the rest of the time is the profitability zone. You can imagine, right? We have a maturity of 1 year, but actually the duration of this investment is only 0.73 years, meaning that actually you could recoup your money or your investment, or you could get back your investment within 0.73 years. And the remaining period, 0.27 years, the remaining period is the profitability zone, profitability period. So simple question before we proceed, right? Do you like a longer duration or a shorter duration?
Shorter duration.
Shorter
Because I
duration, right?
get earlier my money back.
That's right? Common sense, right? So you could imagine now, the shorter the duration, the faster, right, in real sense or in real term, you recoup your investment, right? You get back your investment. And the rest of the period will be the profitability period or profitability zone, right? And we'll see a lot of examples today, okay? So that's the first idea. You see, duration and maturity are not the same. Both of them show the time, of course, but they are not the same, right? So again, coming back to the definition. So duration is the weighted average time to maturity. Now you can understand the definition better, right? A weighted average time to maturity with the present values of cash flows being the weights, right? If you see the formula again, the weights are the present values, right? Present values of cash flows, right? So this is like weighted average time to maturity with the present values of cash flows being the weights, right? Like call it duration. Right? So we'll see a lot of characteristics of duration, features of duration, but after we see a lot of examples, okay, we'll come back here. So again, this is the weighted average time to maturity, with the present values of cash flow being the weights. So the features here, we'll come back later, okay? So we'll see a lot of examples. So first example here, duration of a 6-year euro bond. So this is I hope you got it from other courses already, euro bond, uh, euro dollar or something, right? So what is the definition of euro bond? Uh, any one of you got this terminology before? What is euro bond? Max, you want to try Max? Or anyone?
It's an European bond, and you can get this bond, and
Yeah.
then you have to pay it back later, and that was with Greek,
Mm-hmm.
I think.
Yeah, could be right. But the funny thing is, we use the name euro because after the Second World War, uh, the United States, was obviously the winner. But then euro was developed afterward. So most of the transactions happen between the American and the European markets. That's why the name is like Eurobond, but actually you could apply this to everything. So the definition here is that you go to another country, okay, and then you issue a bond uh, in your using your home currency. So you can imagine, right? If you are, uh, for example, an American company, okay, American company. So you go to Germany and then you issue the bond, right, in US dollar. This is called what? Eurobond, right? Eurobond. Okay. But you can do it like again, this is the funny thing, right? If you are a German company, right? You're a German company, you come to wherever you come to Singapore, okay? And then you issue a bond, right? You issue a bond in euro. What is the name for this? Very easy, right? Euro bond. You see the point, right? So you go to another country, right? You go to another country, but you issue a bond using your home currency. That is called euro bond. Right? What about this? You're a German company, right? You go to the United States, but you issue a bond in US dollar. What is the name for this?
US bond?
This is called Yankee Bond. You heard of the name before, right?
No, we didn't have this in our courses.
Okay. So
And
yeah,
I wanted to say that the maturity of these bonds are midterm or long term.
could be both, could be intermediate, could be long term. But it's just a terms of like naming, okay? The funny thing about the naming things. But again, if you're a German company, you go to the United States and you issue a bond in euro. What's the name? What is the name for that?
Eurobond.
Eurobond. Eurobond, you see, right? But if you're a German company, you go to the United States and issue a bond in US dollar. What's the name?
The Yankee Bond.
Yankee Bond, right? Yankee Bond. So one more example, okay? If you go to Japan, you are German, right? You're a German company. You go to Japan and you issue a bond in euro. What is the name?
German bond?
Eurobond.
Yes,
Eurobond.
Eurobond.
Eurobond, right? But if you go to Japan, right? You're a German company. You go to Japan and you issue a bond in yen, Japanese yen. Do you know the name for this? Yeah, it has a special name, right? You're a German company or whatever company, right? Whatever nationality, right? You go to Japan, but you issue a bond in Japanese yen. The name is Samurai Bond. Okay. Yeah, that's the funny thing, right? So you use the term Eurobond for everything. So you go to another country, if you issue a bond denominated in your home currency, then you call it Eurobond, right? Okay, so we go back to this example here. So 6-year Eurobond, you can imagine, it means that this is what maybe American company going to Europe, but issuing a bond denominated in US dollar. So Eurobond pay coupons annually. The maturity is 6 years. Annual coupon is 8%. This is the face value or the par value, okay? The par value of the bond. I hope you still remember the face value means this is the amount that you will get at the end of the period or at maturity. So if you hold the bond until maturity, then you will get 1,000, right, per bond. And then this is important information. The current yield to maturity is the same, still 8%. So you see there are two 8% here. Have to be careful here. Let me. So this is the coupon rate, but the other one is the current yield. Right? Current yield is the market rate. This is the annual coupon rate, 8%. I don't know. Maybe you took the some finance and accounting courses in the past, and here's the difference. So Dina, okay, Dina, tell me, okay, if you want to issue a bond, right, you want to borrow money from the bondholders, right? Let's say you are uh, whatever company, maybe a manufacturing company, an automobile company, right? You are a German automobile company. You want to borrow money by issuing a bond, and you have to offer certain interest rate, right? Certain coupon. We call it coupon payment. So you're offering like interest rate to your potential buyers, the buyer of the bond. So tell me, Dina, how would you determine the number here? Uh, Maybe 6%, 7%, yeah, whatever, 8% or anything. And finally, you decide on this one, 6%. Tell me what is the logic of determining the interest rate here that you will promise to your buyers? You don't need any theory, Dina. Just imagine using your common sense, right? So you want to borrow money, right, from bondholders, you have to promise interest rate, right? How do you determine the interest rate? Why do you finally decide on 6% or 7% or 8% or anything?
If I have to pay the interest rate, I would go
Mhm.
for the lowest one. So out of
Mhm.
6, 7, and 8, I would choose 6%.
Yeah, that's right. That's right. Yeah, that's so true, right? Uh, but firstly, this interest rate that you offer has to be higher than something else. That something else is the risk-free rate. Remember our discussion, right? The interest rate offered by a government securities, right? For example, if the risk-free rate right now is, let's say 2%, okay? To make it easy to imagine, okay? The risk-free rate is 2%. Then when you want to borrow money as a company, you want to borrow money from the bondholders, how much percent should you give? More than 2% or lower than 2%? If the government securities pay 2%, how much should you give? More than 2% or lower than 2%?
More than 2%.
Why is that? Yeah, that's correct. Why is that?
Because there's also risk when buying your bonds, and the free rate would be 2%, which is lower, but you have to give them something for why it's worth for them to pay a higher interest rate.
Exactly, right? You see, if the government securities already give 2%, you cannot give 2% also, right? Or even lower than 2%. Even cats will not buy, okay? Cats on the street will not buy your bond because the government already give 2%, right? And the government is considered risk-free. Of course, we discussed this several days ago that the government and the central bank actually could go broke, right? Pragmatically or practically, they could go broke, but it's very difficult for them to go broke because they have uh, a lot of policy power, right? They could print more money, they could sell the land. Remember our discussion, right? So we consider government securities to be risk-free, right? We consider, right? So if the government securities already pay 2%, definitely if you want to borrow money, you have to offer more than 2. But here's the thing, right? More than 2% could mean anything, right? Could mean what? 3, 4, 5, 6, 7, 8%, and so forth, right? But if finally you choose 6%, why is it? Maybe I continue with Dina already, Clara already. Uh, who else here? Maybe Patrizio. Going back to Patrizio.
What was the question? Sorry.
So it should be more than the government securities interest rate, right? So in our example here, the government securities already pay 2%. So definitely you have to pay more than 2%, right? But what is above 2%? It could be anything, right? Could be 3, could be 4, could be 5, could be 9, could be 11. But if you finally decide uh, to offer a coupon rate of 6%, why is that so? Why do you choose 6? Why not 5? Why not 7? Why not 8? What is the logic there?
It's 3 times what the government is offering, but mm, I don't know.
Anyone else? Alina,
Maybe
you want to try?
maybe it
Oh,
should
Clara?
depend.
Yeah.
I think that it should be depending on the risk.
Yeah, that's
Like,
right. Very good answer. Yeah.
riskier
Continue.
to,
Go ahead.
if it's riskier to give you money, you should offer a higher interest rate, but
Mhm.
still the lowest, which would be possible. So I think there would be like some calculation behind it to calculate the risk.
That's right. Yeah, that's so true, right? So it should be above 2%, but now what is above 2%? There are a lot of numbers. So if you finally decide on 6%, this would mean that here's the thing, right? So you issue this bond, you know, uh, when you issue a bond, there are a lot of uh, in the contract there are a lot of clauses, right? A lot of clauses. uh what is the collateral for the bond, and then how to pay the bond and everything. So we call it like one package of risk characteristics. So if you finally decide to pay 6% per year, it means that 6% is the market risk, right? Is market risk for this kind of bond with this kind of risk characteristics, right? You see, you don't need any theory to imagine this, right? I want to issue this kind of bond, and I finally decide to pay 6%. Why do I choose 6%? Because 6% is the market interest rate for this kind of bond with this kind of risk characteristics, right? So, Alina, tell me, if the market risk for this kind of bond with this kind of characteristics should pay 6%, what if you issue the bond and pay 7%, Alina?
I would always choose the cheaper interest rate.
Yeah, that's right. So,
It shows
again,
the risk,
that's
but
right.
it shows,
So
yes.
imagine the situation again, right? I repeat the situation. So market risk for this kind of bond, right? For this kind of risk characteristics is paying 6%. This is the market rate, right? 6% for this kind of bond. But if you pay 7%, are you happy or unhappy?
I'm unhappy
Why?
because I have to pay more interest rates.
You pay too much, right? You pay
Yes.
too much, so you will not do it, right? You will not do it. So, Karina, if you decide to pay 5%, what will happen?
I would be happy because I would pay a lower interest rate than
Yeah.
for the market interest rate.
You will be happy, but what will happen to the bond? Who will buy the bond?
No one will buy it since
Yeah.
you get a lower interest rate than the risk is set.
Right. Yeah, so not many people want to buy the bond. That's the problem, right? You see, so the what's that? The center of our story here is that when we issue the bond at the first time, the coupon rate that we offer should be the same or at least very similar to the market rate for this kind of bond with this kind of risk characteristics. So my point here is that when we issue the bond, the coupon rate and the market rate were the same at the beginning, right? So we don't need any theory to imagine this one, right? So imagine again the situation. The market rate for this kind of bond is 6%, right? For this kind of risk characteristics. If we issue the bond and pay the coupon rate of 5%, nobody wants to buy, or very few people want to buy. But if we issue it with 7% coupon rate, many people want to buy it, but we lose money, right? Because we pay too much. Like what Alina did, right? 7% is more than necessary. Many people want to buy, but we are losing money here. So definitely, you see, when we issued the bond here, coming back here, when we issue the bond and we pay 8%, we can be quite sure that at the beginning, the 8% coupon rate is exactly the same as the market rate. You can call it market yield or market rate, right? So they're the same at the beginning, right? At the beginning. So here's the thing, right? Once you issue the bond and you promise something to the bondholders, this cannot change anymore. Okay. So again, for example, Karina, you say to the bondholders, I issue this bond and the coupon rate is 6%. So this cannot change anymore, right? Throughout the bond period until maturity. However, the market interest rate keeps changing from time to time. Right? You see this also in our previous chapter, right? The market interest rate keeps changing, but the coupon rate cannot change anymore because that is your promise, right? You promise to give 6% to the bondholders. This will last forever until, or this will last until maturity. But the market interest rate will keep changing from time to time. Okay, so that's why you see this story here. The story here, we have two interest rates. We have to be careful. The annual coupon rate is 8%. But the current yield is also 8%, meaning that they are still the same. Okay, and this story, this is a simple story, and we'll see in subsequent examples, they will be different. Okay, but in this story, they are still the same. So I hope you understand now the difference, right? Annual coupon rate is the one you promise. And of course, at the beginning, the coupon rate would be the same or at least very similar to the market rate for this kind of bond, for this kind of risk characteristics. Okay, so let's draw the story here. 6 years, 8%. Okay, let me do it here. So how many years again, the maturity? 6, is it? Okay, so the coupon rate is, what is the coupon rate again? 8%, is it? Coupon rate is 8%, right? And then the face value or the par value is 1,000. So you pay 1,000 here, right? At the you get 1,000 if you're a buyer. If you are the issuer, you pay 1,000 at the end. So just suppose that you're a buyer, so you get 1,000 there, and then the coupon rate is 8%. So how much is it? 8% of 1,000?
$80.
Yep. So this is what you get, right? 80, 80, and at the end 1,000, based on this information, right? Yep. And yes, 6 years. But the market rate or current yield is still 8%. So this is by what's that? By design or no, by design of the example, the coupon rate and the market rate are still the same. Okay, so from time to time they will be different, but in this example they're still the same. So let's calculate now the duration. So the yield is 8%. Right? This is the market rate. Okay, the coupon rate has been reflected here. You see the coupon payment. Right? So the R here is the market rate. Okay, so let's calculate the duration. So from the denominator first, right? Denominator. What is the first cash flow? 80. So 80 divided by 1 plus 8%. So what? Tell me, what is the 8% here? This is market rate or coupon rate? Because both of them are the same, but what is it?
Is that market rate?
Market rate. That's very good. This is the yield, okay? The market rate. But in our example, it's still the same, so have to be careful. The 8% here is the market rate. So to the power of 1, because it's one time, right? Okay. So plus the second one, 80 divided by 1 plus market rate to the power of
2.
to the power of 2, not because it's 2 years, okay? But there are two movements here, you see? 1 and 2. 1 and 2.
Yes.
And so forth, okay? So we'll not write everything. Or maybe the last one. What is the last cash flow? 1,080. Market rate to the power of?
8.
I don't think so. To the power of
6.
6. Yeah, to the power of 6. Right? Okay. Okay, we'll calculate using Excel. Whether here's an important lesson for you. Okay, in modern accounting and finance, we will never calculate by hands. Okay, even in your exam or everything, you will not calculate by hands. But you have to know how to calculate by hands. Two different things, right? You have to know how to calculate them, but you will never calculate by hands. But you have to know the logic. So what is the numerator? The numerator, so 80 divided by 1 plus 8% to the power of 1 multiplied by the real time here. What is the real time for this one?
1.
1, yes. Plus, yeah, and so forth, right? The second one, the power of 2 times year 2, right? And the last one would be, what's it? 1,080 divided by 1 plus market rate to the power of 6. times 6. This is the real time, right? Okay, so we'll do it in Excel. This would be very easy. So this is the cash flow. 8%, right? 8% of 1,000 is 80. And the last one, you get 80 and 1,000. Right, based on this this picture, right? Okay, now what is the present value again? The the first one, 80 divided by 1 plus. Remember, what is the 8%? Yeah, what is it? What rate is it?
Could you repeat it? Yeah.
Yeah, is it market rate or coupon rate?
Market rate.
Market rate, yeah, be careful, right? To the power of 1, right? To the power of 1. And I can make copy paste, right? But maybe one more line, and we make a copy paste. So what is the second one? 80 divided by 1 plus
8%.
To the power of
2.
I make copy paste, right? To the power of 2, 3, 4, 5, 6. Okay, and then we sum them together. Okay, so you get the denominator. This is the denominator, right? And then to get the numerator, we have to multiply each present value by the real time. So this one is easy, right? Because the periods are exactly the same as the time. So year 1, year 2, year 3, year 4, 5, 6. And then we find the multiplication, right? Present value multiplied by its respective time. Okay. Okay, and then you sum them. You sum them. We get, this is the numerator, right? This is the numerator. This is the denominator. So the duration would be numerator, right, divided by the denominator. So 4.99 or 5 years. Let's say 5 years. So imagine, remember our story here. How long is the maturity?
6 years.
Yeah, 6 years, and the duration is about 5.
5 years.
Yeah, 5 years, right? So maybe Patrick, can you interpret this for us again? Can you interpret this situation? So the maturity is 6 years, but the duration is 5 years. What's the meaning? So within 5 years, what can you say about the finding here?
I don't know.
Anyone? So the maturity is 6 years, but duration is 5 years.
The 5 years is the amount of time we will need to get the money back, and afterwards is a profitable time of 1 year.
Exactly, right? So yeah, this is good, right? Because within 5 years, actually, you have recouped all your investment or get back, the investment results, right? And the remaining 1 year is the profitability period, right? Profitability zone. So the shorter the duration, the happier you are, of course, right? Okay, so yeah, we still have a lot of examples, don't worry. So any question first about the calculation before we move to another example? Quite easy to understand, right? Especially with Excel. Again, I want to emphasize this, right? So you have to know how to calculate by hands, right? You have to know it, but you will not calculate by hands because we have a modern technology like this, right? Why should we calculate by hands? But we have to know the logics and the mechanisms of the manual calculations. Okay, so yeah, let's go to the next example. Okay. So still similar bond, but now the example changes some inputs. The face value is 1,000 as usual, right? This is the amount of money that you will get at the end of your investment or at maturity. Annual coupon rate is 8%. Now here's the thing, right? The annual yield to maturity is 12%. So now you can imagine the story. We have promised our bondholders to get 8%. We promise to give them 8%, and this cannot change anymore, right? So again, from our previous discussion, we could imagine that why at the first place we offered them 8%, because when we issued the bond, 8% was also the market interest rate for this kind of bond with this kind of risk characteristics. You see, that's why we offered 8%, and this offer cannot change anymore. This will last until maturity. However, you see the fact here, the annual yield has changed to 12%, right? So the market rate has changed to 12%, but the coupon rate that we have promised can never change. But the coupon rate of 8% was decided because at that time, 8% was also the market rate when we issued the bond, right? Okay, so let's draw the situation again. I will use Excel to finish.
I
Yes,
got another question.
yes.
Since the annual yield is higher, even if it's not higher, why aren't we reinvesting the money we get back? So the actual duration would be lower because we would reinvest and get money from that. So we have an even shorter duration. Shouldn't we include that?
Yeah, that's very good observation. You will find out that, of course, the duration will be shorter, right? Because the reinvestment rate would be higher, right? So when you get the money from time to time, you reinvest the money at a higher rate. Very good observation, and this is actually one of the features that we saw in previous slide. But we will go back later after we see all the examples. Yeah, very good observation. Yeah, good one. So we'll solve this one first. Okay, still 6 years. And the coupon rate is the same. It cannot change anymore. What is it again? We get 1,000. So the coupon rate is 8%. So tell me again, what is the coupon payment per period? 8% of 1,000? What is it again? 80, is it? Okay, but now the coupon rate is what's that? 12, right? 12%. Okay. Oh, and now we have to be more careful because now this is semi-annual. So you see the previous example was annual. Okay, so we have to be careful. This one is semi-annual. So how many periods do we have?
12.
Yeah, 12 periods. So yeah, we cancel that one, okay? So we do a new one. So we have 1, 2, and so forth, and 12. So this is not empty, okay? I'm just lazy to write, so it doesn't mean that it doesn't pay anything, but so we'll get 1,000 at the end. So what is it again? Coupon rate is 8% per annum. So how much is it per 6 months?
4%,
Yeah. So how much is it?
40
Yes.
euros.
So 40. All right. I don't write it, but it doesn't mean that it doesn't exist. Okay. Just lazy to write. All right. So 40, right? 40, 40, 40, and then 40 and 1,000. Now the market rate is 12% per annum. Be careful, per annum. So per semester, this would be 6%, right? So the market rate is 12% per year, the annual market rate. So let's recalculate here. We can do it on Excel. make it quicker. So we have see. Oh, actually, the example here is 2 years, right? Yeah. So if it's 2 years, there are only 4 periods. I didn't look carefully. So we only have 2 years. Yeah, even easier. So the first one, is it 40 divided by 1 plus, what is it? The market rate?
4%.
The market rate is
To 12%.
the market rate is 12% per year. So 12 per 2, right? 6. Yeah, to the power of 1. And then the second one, 1 plus 12% divided by 2 to the power of 2, right? 2 times here, 1, 2. And yeah, till the last one. What about the numerator? 40 divided by 1 plus market rate divided by 2. And before we add with another cash flow, we times the what is the period here? Period number 1 is how many years?
Half a year.
Half
So
a year.
times 0.5.
That's right. And then the second one, 40 to the power of 2 times what year is it? 1 year.
Times 1.
Times 1, and then so forth, right? 1.5 and then 2. Okay, so we only have 2 years. Semi-annual, but 2 years, but semi-annual. And coupon rate is 8%. 8% of 1,000 is 80 per year. So per semester, it would be 40, right? 40 at the end of year 2, we'll get 1,000. So tell me again the present value. 40 divided by 1 plus what?
6%.
Again, why is it 6?
It's 12% divided by 2. Since
It's
semi-annual.
actually, that's right. So 12% is the market rate, but this is semi-annual, right? To the power of 1. Right? And then we make a copy, right? To the power of 2, to the power of 3 and 4. And then we sum them. So we get the denominator, right? This is the denominator. And then to get the numerator, we have the time, the real time here. This is periods 1, 2, 3, 4. In real time, this would be half a year, 1, 1.5, and 2. Right. So the present value multiplied by the time, and then copy paste. Then we sum them together. So we get the numerator, right? So duration is the numerator divided by the denominator. So 1.88. What is the maturity again?
2 years.
2 years, but the duration is only 1.88. So let me use it here. Maybe Max again. Max, can you interpret this result again? The maturity is 2 years, huh?
Yeah, we get our money back after 1.8 years, and yeah, so that's good for us.
Good for us. Yeah. Not that significant, right? The difference because yeah, we only have 2 years. So you could imagine we only have 2 years, so we could enjoy the profitability period for a short time also. Difference from the previous example where we had 6 years, right? 6 years. So we could get back everything in 5 years, and there's 1 year for profitability zone. But this one is quite short. Okay, so maybe one more example, okay? One more example before you go. Let's try this one. Okay. Yeah, what about this one? So similar example, but coupon rate is now 6%, and uh, the market rate is 12%, and semi-annual. Right? This is semi-annual. 2 years semi-annual. So let's do it quickly and then do Excel. So how many periods again do we have? 2 years semi-annual?
4.
4, yes. And what is it? Coupon is 6, market is 12. So how much is the coupon payment? 6% of 1,000? 60, right? But per semester, this would be 30. Okay? 6% per year, right? So per semester, it would be 3% of 1,000, which is 30. And then the market rate is 12% per year. Be careful, 12% per annum. So let's do in Excel. Okay, 30, right? So what is the present value, the first one? 30 divided by what?
1 plus 6% in the power of 1.
6% because the market rate is 12%, but this is semi-annual, right? So 12 per 2. Okay, make a copy and paste. Then we'll get the denominator. Okay, and then again the same thing here, the time, right? So half a year, 1 year, 1.5, and 2 years, the real time, right? So we multiply each present value by the real time. We make a copy and paste, and then we sum them together. We get the numerator. The duration is the numerator divided by the denominator. So 1.9, 1.9 years. So 1.9 years. The maturity is 2 years. And again, the duration is 1.9. Right? Okay, so yeah, there are 2 more examples. Maybe we can do it quickly, okay? Maybe 5 more minutes or something. So the next one is, what's the difference here? The coupon rate is 8%. The market rate is 16%. Still the same thing, right? 2-year bond semi-annual, 2-year bond semi-annual, with a coupon of 6% and market rate of 12%. So 2 years semi-annual, the same thing.
Where always semi-annual? Does it say it is semi-annual?
Yeah, this is still semi-annual. You see
You
here?
see it with the time, with the health.
Okay, okay. Thank you.
Yeah, so 2 years but semi-annual. So we have four periods. Right? So 6% coupon. So 6% of 1,000 is 60. Right? Yeah, like before, but semi-annual. So 30. What's the difference now? The market rate is, oh no, this one 16%. Oh, this has changed. Sorry. So this is 40, right? 40. Look at the wrong slide. So this one, right? So 8% coupon. So 8% of 1,000 is 80, but in semi-annual, this will be 40. And then 16% market rate. Be careful, this is per annum. Right? Let's put into Excel. Yeah, we can copy everything here, but let's do it again. So 40. So tell me the present value again. 40 divided by, what is the market rate?
6%.
Maybe not this one. This one is 16.
Yes, 16.
But divided by 2, right? Be careful, semi-annual. So
8.
8, yeah. To the power of 1, right? And then we make a copy and paste, power 2, power 3, power 4. Okay, and then the real time. So we multiply. Then we get the numerator. Right, 1.87, right? 1.87 for this one. So again, the maturity is 2 years, but the duration is only 1.87 years. So there, yeah, we'll finish off maybe one more example, yeah, this one. So this is only 1 year, but semi-annual, right? 1 year semi-annual, 8% coupon and 16% market rate. So how many periods do we have? 1 year, but semi-annual.
2 periods.
Only 2 periods. Yeah, only 2 periods here. So what is the cash flow again? You get 8% of 1,000, 80, but semi-annual,
40.
40, yeah. 40 and 1,000, right? So the present value would be 40 divided by what? What is the market rate? 16. So 1 plus
8%
semi-annual.
to the power of 1.
That's right. Copy and paste. Now you get the denominator and the time here, half year and 1 year. Okay, the duration is the numerator divided by denominator. So, yeah, you see, because the time is short, the duration is also very close to the maturity, right? The maturity is 1 year, duration is 0.98, so almost all. So, before we end the session here, I want to come back to this one, the features. Now we understand the features of duration. Yeah, this one, right? So the first feature, duration increases with maturity, but at a decreasing rate. So you understand the meaning, right? So the longer the maturity, the longer the duration, of course, right? But the increase in duration doesn't follow the linear progression. So it doesn't replicate the increase in maturity. So we prove it here. We have proved it in Excel. For example, you compare maybe which one? Yeah, I think these two, right? You see, they're exactly the same, except that this is like 2 years, this is 1 year, because they have the same coupon rate, right? The coupon rate is 8%. So the coupon rate are the same, and then the market rates are also the same. So the coupon rate is 8%, the market rate is 16% per annum, right? You see here, the maturity is 2 years. This one, the maturity is 1 year. But the duration here is what? 0.98, right? So for the 1 year bond, with all things the same except the maturity, right? For the 1 year bond, the duration is 0.98. But for the 2 year bond, the duration is 1.87. So if you multiply this by 2, it should be what? 1.96, right? It's not 2, right? But the duration is 1.87 only. So you see, you understand the first point here is saying that the longer the maturity of an asset or a bond, the longer the duration will be. However, the increase in duration is not linear, or is not the multiplication of the increase in maturity, right? So what about the second one? Yeah, Clara mentioned this, right? The second one, you see, decreases as the yield on security increases. So let me ask who's that? Dina, maybe Dina, right? So the higher the market rate, right? The higher the market rate, for example, we saw the example 8%, 12%, 16%. Okay, the market rate will change, right? This is something that can change. So the higher the market rate, the shorter or the longer your duration. Clara mentioned this before, right? So the higher the market rate, what is the consequence there?
The shorter the duration.
The shorter the duration, that's correct. Why is that? Just use your logic, okay? You don't need any theory for this. If you have a higher market rate, what is the consequence? Can you reinvest the money at a higher rate or at a lower rate if the market rate is increasing?
At a lower rate?
If the market rate is increasing, then you can reinvest the money at what? At a higher rate or lower rate?
At the higher rate.
At a higher rate, right? You see here? Yeah, maybe this example here. The coupon rate is 8%, right? That's why you get 40. Once you get the 40 here, you will reinvest the money. You will not let the money slip, right? You get the money and you reinvest again. But now you could reinvest the money at a new rate here, 8% per semester or 16% per annum, right? So simple question, right? If you get the money, you get the 40, and then you want to reinvest, and the market rate has increased. Are you happy or unhappy?
Unhappy, right?
Happy, very happy, right? You get the money, you reinvest the money, and then the market rate is going up. You are happy, right? That's why the duration is shorter or longer. Which one will make you happy? Shorter, right? Shorter duration will make you happier, right? Okay, that's why you see the second one here. Duration decreases as the market rate increases. Now it's easy to imagine, right? If market rate increases, that means you could reinvest your money at a higher rate. Happier, right? You will be happier, and of course the duration will be shorter. So your ability to get all your investment back will be shorter. But the ability to get the reinvestment back will be higher, meaning that the duration is shorter, right? So let's see the third one, right? The last one here. duration decreases as the coupon rate increases. So, actually, the second one can be proved here. So we go back a bit, okay? The second one, let's see what examples. This is what? This is 12%. Yeah, maybe with this one. So you see here, this one, this is again for the second point, okay? The coupon rate is 8%. The market rate is 12, right? And this one is, see, the coupon rate is 8%, but the market rate is 16. You see, the duration for this one is 1.88, whereas for this one is 1.87. See, faster, right? The second point. So the higher the market rate, the shorter the duration would be, right? Because you can get the money back faster because the market rate has gone higher, right? What about the third one? The relationship between the duration and the coupon rate. So, Karina, tell me the logic, the relationship between duration and the coupon rate. Now the coupon rate.
If the coupon rate is low, the higher is the duration.
That's right. What is the logic?
Because the coupon rate is in the denominator.
Coupon rate is the numerator.
Yeah,
but
the numerator,
just use the the numerator and also denominator. But just use your logic, right? If the coupon rate is lower, like what you say, what does it mean there?
Would it mean that you get your money back faster and could also reinvest more money at a quicker time?
If the coupon rate is higher, right?
Yeah.
But if the coupon rate is lower, like what Karina said, then you got back your money slower. Common sense, right? Because the coupon rate is lower, then you get less money, right? Every semester or every year or every month, you get the money, you get less money, right? Meaning that the length of period at which you could recoup your investment will be slower. Right? That's why the opposite direction. And what Kara said, the higher the coupon rate, the faster you get back the money. Common sense, right? So you don't need any theory to explain this, right? So you get, if the coupon rate is higher, you get more money per semester or per year, meaning that you could get back or you could recoup your investment faster. Okay, so let's prove this again in our Excel. Maybe between this two, I think. Let's see. Yeah, that's right. So you see this one, the coupon rate is 8% with the market rate of 12 per annum. This one, the coupon rate is 6%, the market rate is 12%. So they are the same with respect to market rate, right? They are the same, but the coupon rates are different. This one 8%, this one 6%. So you see what happened here? The duration for this one is 1.88. But the duration for this one is 1.90 on 1.91, right? This one is shorter. Why? Because the coupon rate is higher with the same market rate, right? With this one, right? So the higher the coupon rate, the more money you will receive every month or every semester or every year. It means that you will recoup or get back your investment faster. And so is your duration, right? Okay, so in our next meeting, we'll see how to use the duration method to manage the interest rate risk, okay? But at least now you understand how to estimate duration. It's not difficult, right? Because we have Excel, we have everything. And again, in case you have this question in your final paper, it will be very easy. You can use anything, okay? Just again, I want to emphasize this point, right? You have to know how to estimate something, but you don't need to do it by hands, right? But at least you have to know the logics of estimation. Any final question for today?
I just got a question for the recording. Will you upload for the recording? So you recorded the session. Will you upload the one on Moodle, or how are we able to rewatch it?
Okay, I will upload it on Moodle or YouTube or anywhere. Yeah, the easiest one. Okay. Yeah. So yeah, have a nice weekend. Enjoy weekend and take care always. Okay, don't go out without any great necessity. Just stay at home. Okay? So see you next week.
Bye.
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 Bye.